Hello students, let us go through the final module of the chapter Atomic Structure. Starting with atomic number, represented as Z. Atomic number of an element is equal to the number of protons present in the nucleus of its atom. So for hydrogen, atomic number is 1 because it has only one proton in its nucleus. Mass number is the sum of the protons and neutrons in the nucleus of an atom. As you can see, carbon 14 having 6 protons and 8 neutrons in its nucleus, therefore its mass number is 6 plus 8, that is 14. Now we take out the number of neutrons, we can subtract mass number, or you can say to find the difference between mass number and atomic number. Represented over here in the form of symbols. A is mass number, which is equals to number of protons plus number of neutrons, or atomic number plus number of neutrons. Example of helium is given over here, mass number 4, atomic number 2, and symbol is He. Moving on to isotopes. Atoms with the same number of protons but different number of neutrons are called isotopes. Isotopes of the same element with and same atomic number with different mass numbers. Example of chlorine is given over here, chlorine 35 and chlorine 37. Now moving on to some other example. We see over here example of carbon given over here, carbon 12, carbon 13 and carbon 14 having different number of neutrons in their atoms. Atomic number being same, that is 6 in all the cases. Atomic mass. The atomic mass of an element is a weighted average mass of the atoms in a naturally occurring sample of the element. The weighted average mass reflects both the mass and the relative abundance of the isotopes as they occur in nature. We will see with example of chlorine, as you see over here, which has an atomic mass of 35.5, and there are two naturally occurring isotopes of chlorine, that is chlorine 35 and 37. Chlorine 35 occurs naturally 75.8%, and 37 occurs naturally almost 24.2%. So from the calculations, we take out that its atomic mass is 35.5. Electronic configuration is the arrangement of elements in an atom. Each element has a distinct electronic configuration. Electronic configuration describes the relationship between energy and also stability. Some examples are given over here. For carbon, it is having 2 and 4 as electronic configuration. Sodium is having 2, 8, 1 because its atomic number is 11, and chlorine is having 2, 8, 7 as its atomic number is 17. Now, these are some of the electronic configuration of first 20 elements given over here. Hydrogen only 1, helium 2, its complete is doublet, lithium 2, 1, like carbon 2, 4, oxygen 2, 6, chlorine 2, 8, 7, calcium 2, 8, 8, 2, etc. Now Valency and valence electrons. What are these? Not to get confused. The number of electrons that are shared, lost or gained by an atom during a chemical reaction is called valency. And the outermost shell of an atom, or because the number of Yeah, it's called the valence shell, and the electrons present in the valence shell is called valence electrons. Like in the outermost shell of sodium, there is only one electron, and that one electron is called valence electrons. And in outermost shell of chlorine, there are 7 electrons, and all those 7 electrons are called valence electrons. So now, moving on to some of the valencies of first 20 elements. Hydrogen is having valency 1, helium 0 because completed doublet, lithium 1 again, beryllium 2, boron 3, carbon 4, nitrogen 3, oxygen 2, fluorine 1, neon 0, sodium 1, magnesium 2, aluminum 3, silicon 4, phosphorus 3, sulfur 2, chlorine 1, argon 0 again, it has completed its octet, and potassium 1, calcium 2. Okay. Now, what is the reason for variable valency? Why it occurs? This property is called of the elements showing different valency. More than one valency is called variable valency. Several elements show variable valency because of the different electronic configurations. An atom of an element can sometimes lose more electrons than are present in its valence shell. That is, loss from the penultimate shell due to the possession of more energy, and hence exhibit more than one or variable valency. So those electrons move out of the shell because of the energy that they possess, extra energy. These are some of the elements showing variable valency: copper 1 and 2, mercury 1 and 2, silver 1 and 2 again, gold 1, 3, tin 2, 4, manganese 2, 4, platinum 2, 4, iron 2, 3, sulfur 2, 3, 4, lead 2, 4, and phosphorus 3, 5, etc. Now, why do atoms combine? Yes, this is a very general query or question. Atoms combine because they are not stable unless their valence orbital is full of electrons. So in order to fill this outer orbital, they'll share, give, or take electrons from other atoms, and therefore they combine, forming bonds, either ionic or covalent bond or coordinate bond. Doublet or octet. Helium has a complete shell of 2 electrons, 2 valence electrons, or doublet condition. Similarly, neon or argon also have 8 electrons, and it is completing its octet condition. These elements are monatomic and are very stable gases or elements. A doublet or octet configuration is also known as noble gas structure or a noble gas configuration, and most of the elements or atoms, they want to acquire this noble gas configuration. Now we'll move on to radicals. What are they? Now, a radical is an atom or an element of or a group of atoms of different elements that behave as a single unit with a positive or negative charge on it. Positively charged radicals are called basic radicals, such as Na+, NH4+, etc. Negatively charged radicals are called acid radicals, such as NO3-, Cl-, OH-, SO4-2-, CO3-2-, etc. So we'll move on to some list of radicals over here. These are the ammonium NH4, nitrate NO3-, nitrite NO2-, bisulfate HSO4, bisulfite HSO3, bicarbonate HCO3-, hydroxide OH-, acetate CS3CO-, sulfate SO4-2-, sulfite SO3-2-, carbonate CO3-2-, etc. So with this we come to an end of the chapter. Thank you.